If an alien civilization, 65 million light-years away, turned a telescope toward Earth right now, they wouldn't see our cities, our wars, or our internet. They would see dinosaurs roaming a prehistoric jungle. This is not science fiction. This is the strict, non-negotiable law of physics. You are living in a universe that operates on a delay. When you look up at the night sky, you are not looking at the universe as it is. You are looking at a ghost town. You are staring into a deep, three-dimensional history book, where every page is a different era, and the present moment is an illusion that exists only for you, right here, right now. To understand why, we have to talk about the speed limit of reality. We are taught that the speed of light is fast. At 299,792,458 meters per second, it is the fastest thing in existence. It is instantaneous enough that when you flip a switch, the bulb floods the room without a pause. It is fast enough to circle our planet 7.5 times in a single second. To a human brain which processes reality in milliseconds, light seems infinite. But the universe does not operate on human scales, and when you step outside the cozy confines of our atmosphere, you realize a terrifying truth. The speed of light is agonizingly slow. Consider the sun. It sits a mere 93 million miles away. That light, traveling at the absolute limit of cosmic velocity, takes 8 minutes and 20 seconds to cross that gap. If the sun were to suddenly vanish, plucked from existence by some cosmic hand, you wouldn't know. You would go about your day for 8 minutes. You would feel the warmth on your skin. You would see the shadows stretching across the pavement, and the flowers would continue to photosynthesize, orbiting a ghost that was no longer there. Gravity travels at the speed of light too, so the Earth would continue to orbit nothingness for those same 8 minutes before we were suddenly flung out into the dark, cold void. We live in a perpetual lag. Now, zoom out, push past the sun, past the asteroid belt, to the frozen edges of our solar system. Think about the Voyager 1 probe, the farthest human-made object in existence. It has been traveling for nearly 50 years, screaming through the dark at 38,000 miles per hour. Yet, it is only 22 light hours away. If we send a command to Voyager, we have to wait almost a full day for the signal to arrive, and another day for the confirmation to come back. That is just the width of our own backyard. When you look at the stars, the lag becomes a chasm. The nearest star system to us, Alpha Centauri, is over 4 light-years away. When you look at it, you are seeing light that left its surface 4 years ago. You are seeing it as it was when you were 4 years younger. If that star went supernova today, we wouldn't know for 4 years. We would sleep soundly while the apocalypse raced toward us across the black ocean of space. But that is just the neighbors. Go deeper. Look at the band of the Milky Way, stretching across the summer sky. That is the light of billions of stars. And looking at it is a form of time travel that defies comprehension. The center of our galaxy is 26,000 light-years away. The light hitting your retina from the galactic core left its source when humans were still hunting mammoths with stone spears. Civilization rose, empires fell, and the Industrial Revolution transformed the planet, all while that single photon was silently traversing the emptiness between the stars only to end its journey in your eye tonight. This creates a profound disconnection. We tend to think of the universe as a place, a stage where events happen simultaneously. But the universe is not a place. It is a time machine. The farther you look, the deeper you dig into the past. This leads us to the ghost town metaphor. Astronomers have taken famous images of the pillars of creation, those towering, majestic clouds of gas and dust in the Eagle Nebula, where new stars are being born. They look solid, permanent, and serene. But evidence suggests that a supernova shockwave may have already destroyed the pillars 6,000 years ago. Because they are 7,000 light years away, the light of their destruction hasn't reached us yet. We are admiring a structure that no longer exists. We are watching a delayed broadcast of a building burning down, marveling at the architecture while the ashes have already settled. For the next 1,000 years, humans will look up and see the pillars standing tall, blissfully unaware that they are looking at ghosts. This realization fundamentally changes how we must interpret the images coming from our most powerful tools, like the James Webb Space Telescope. When the JWST captures those dazzling high-definition images of deep space, it is not just taking pretty pictures, it is hunting for baby photos. The telescope is an archaeological tool. It captures infrared light that has been traveling for 13 billion years, stretched out by the expansion of the universe itself. We are looking at galaxies as they formed merely 300 million years after the Big Bang. We are seeing the universe in its infancy. These galaxies don't look like the majestic spirals of the Milky Way or Andromeda. They are messy, chaotic blobs of light, clumping together in the violent first epoch of creation. But here is the mind-bending part. Those galaxies are not there anymore. Over the last 13 billion years, they have merged, evolved, aged, and perhaps died. The stars that generated the light we see today burned out billions of years ago. Any civilizations that might have risen in those galaxies have lived their entire history, from Stone Age to transcendence to extinction, and their home has been swept away by the cosmic flow. Yet to us, they are just being born. We are trapped in a bubble of now that is incredibly small. The only thing you can truly say exists now is what you can touch. Everything else is a memory. The moon is 1.3 seconds in the past. Mars is 12 minutes in the past. Andromeda is 2.5 million years in the past. If there is someone in the Andromeda galaxy looking at us with a telescope powerful enough to resolve the surface of Earth, they do not see the Great Wall of China or the pyramids. They see the African Rift Valley and the early ancestors of humanity learning to walk upright. We are invisible to the rest of the universe, hidden behind the curtain of light-speed delay. This brings us to the concept of the overview effect, but with a temporal twist. Astronauts often report a cognitive shift when viewing Earth from orbit, a realization of fragility and unity. But when you view the universe through the lens of time, you experience a temporal overview effect. You realize that we are isolated, not just by distance, but by chronology. We can never have a conversation with the cosmos. A hello sent to the nearest galaxy takes 2.5 million years to arrive. A reply takes another 2.5 million. 5 million years for a single exchange of greetings. In that time, the human species could evolve into something entirely unrecognizable or wipe itself out completely. Communication implies a shared present, a synchronization of existence. The universe denies us this. It forces us to be observers, silent watchers of a movie that was filmed eons ago. We are detectives walking through a crime scene where the culprit left the building before the Earth was even formed. And yet, this delay is the only reason we can understand our origins. If light were instantaneous, the night sky would be a blinding white wash of all the energy ever emitted, or perhaps a confusing jumble of the current state of the universe. Because light takes time to travel, the history of the cosmos is laid out for us like strata in a canyon wall. We can look at the moon to see the recent past. We can look at Jupiter to see a bit further back. We can look at the nearby stars to see the last century, and the distant galaxies to see the dawn of time. The universe has preserved its autobiography in the flight of photons. But let's look at what this vastness actually looks like. When the Hubble Space Telescope, and later the JWST, pointed their lenses at a tiny dark patch of sky, a patch the size of a grain of sand held at arm's length, they didn't find emptiness. They found thousands upon thousands of galaxies in a sliver of sky that you could cover with your thumb. There are trillions of stars, each with their own planets, their own histories, their own potential for life. And that is just one grain of sand. The entire sky is a beach. This scale triggers a specific kind of psychological pressure known as number numbness. The human brain evolved to track a few dozen tribe members and walk a few miles a day, simply shuts down when confronted with numbers like billions of light years. We cannot process it, so let's break it down. Imagine the entire observable universe is the size of the Earth. In this scale model, our entire galaxy, the Milky Way, home to hundreds of billions of stars, is the size of a CD-ROM placed somewhere in the middle of the Pacific Ocean. And our solar system? It is invisible. It is smaller than a single atom on the surface of that disk. You, your life, your memories, and everyone you have ever loved are existing on a subatomic speck, on a piece of plastic, drifting in a planetary ocean. This vastness is composed mostly of silence and void. We see the shiny parts, the stars, the nebulae, but they are the exception, not the rule. The universe is 99.99% empty space. It is a dark, cold, indifferent vacuum where matter is a rare anomaly. To look out into space is to look into a deep, swallowing dark that goes on forever. And this brings us back to the paradox of the alien and the dinosaur. It highlights the ultimate barrier, the speed of causality. It is not just that light is slow. It is that information itself has a speed limit. Nothing, no signal, no gravity, no influence can travel faster than light. This means that parts of the universe are forever cut off from us. As the universe expands, distant galaxies are pushed away faster than light can travel toward us. They are crossing a cosmic event horizon, disappearing from our view forever. Their light will never reach us. They are falling off the edge of the map. So when you look at those James Webb images, with their six-pointed stars and swirling red galaxies, remember what you are seeing. You are not seeing a place. You are seeing a time. You are seeing the ghosts of the past dancing in the dark. You are witnessing the baby photos of a cosmos that has long since grown up and moved on. We are akin to a person standing in a vast, dark field, holding a single candle. We can see the grass immediately around our feet. That is our solar system. We can see the dim outlines of trees in the distance. Those are the nearby stars. But beyond that, we see only flashes of lightning from storms that raged millions of years ago. We are alone in the dark, piecing together the story of a storm that has already passed, wondering if anyone else is out there in the black, holding a candle of their own, looking back at us. But if they are, they don't see us. They see the dust from which we came. We are waiting for our light to reach them, a message in a bottle cast into the ocean of time, hoping that one day, millions of years from now, someone will look at the faint yellow dot of our sun and realize that, for a brief, shining moment, we were here. This temporal isolation is the first key to unlocking the enigma. It tells us that what we see is not what is. But if the universe is a time machine, what exactly is the structure of this machine? If we could step back and see the whole thing, not just the past, but the shape of the entire cosmos, what would it look like? We are not just drifting randomly. We are flowing, Our galaxy, along with thousands of others, is being dragged through the dark at incredible speeds towards something massive, something hidden, something that acts as the beating heart of our corner of the universe. To understand where we are going, we have to stop looking at the time and start looking at the map. We have to zoom out from the ghost town of the past and look at the terrifying, beautiful structure of the present. We are part of a river of galaxies, a vascular system of light flowing through the void. And this river has a destination. You have felt the weight of time. Now you must feel the pull of gravity. Because while light allows us to see the past, gravity is the hand that shapes the future. And something out there is pulling us. Something colossal. We are merely specks of dust, caught in a cosmic wind, drifting through a cathedral of space-time that is far larger and far stranger than you have ever dared to imagine. The time machine has shown us where we came from. Now, we must turn our eyes to where we are going. The static picture of the night sky is about to begin moving, and the direction it is moving in tells us a story that is both majestic and terrifying. Welcome to the Laniakea Supercluster. Welcome home. Welcome home, we called it. The Laniakea Supercluster. A vast, glowing vascular system of 100,000 galaxies pulling us gently toward a beating heart we may never see. It sounds comforting, doesn't it? To belong to something so grand, to have a biological address in the cosmos. But there is a shadow cast by this colossal structure, a realization that turns comfort into a profound and chilling isolation. When we say home, we usually mean a place we can explore, a place we can traverse from room to room. But the universe is not that kind of home. It is a home where the walls are moving away from you faster than you can ever run toward them. We have a problem, you and I. It is a biological problem. Your brain, evolved to track prey across a savanna and navigate social hierarchies in small tribes, is fundamentally incapable of processing the reality of where you are. You suffer from number numbness. When I tell you that the observable universe is 93 billion light-years in diameter, the number slides off your consciousness like water off glass. It means nothing. Billion is just a sound. Light-year is just a sci-fi buzzword. We nod. We pretend to understand, but we don't. We view the cosmos through the safety of screens and textbooks that shrink galaxies down to the size of a coffee table, tricking us into feeling like masters of this domain. We feel big because our maps are small. So, let's destroy the map. Let's cure the numbness. I want you to perform a mental act of compression. Imagine for a moment that we take the entire observable universe, that incomprehensible sphere of existence, stretching 46 billion light-years in every direction, and we shrink it down. We crush the void, compressing the darkness until the entire observable universe is the size of the planet Earth. In this model, the edge of the universe is the atmosphere, and everything we have ever known is contained on this single planetary surface. Now, where is home? Where is the Milky Way? You might expect it to be a continent, perhaps the size of Asia, sprawling across this cosmic Earth, or maybe a country like the United States, or even a city like New York. You would be wrong. In this scale model where the universe is the size of the Earth, the Milky Way galaxy, our massive city of stars, containing hundreds of billions of suns, is roughly the size of a single CD-ROM. Picture it, a standard plastic disc sitting alone in the middle of the Pacific Ocean. That is us. That is everything we can see with the naked eye. And the solar system? Our sun, Jupiter, Saturn, the Earth. On this scale, the entire solar system is less than a single atom on the surface of that CD. We are not just small. we are effectively invisible. We are a ghost in the machine of our own galaxy. And the nearest neighbor, the Andromeda Galaxy, it is another CD floating about 8 feet away from us in that vast ocean. Does that distance, 8 feet, sound manageable? It sounds like you could just step across the water and touch it. And this brings us to the second, more terrifying part of our reality. The distance isn't the true villain of this story. The villain is the speed limit. We are raised on a diet of science fiction that lies to us. We see ships engaging warp drive or hyperdrive, blurring the stars into streaks of light as they cross the galaxy in hours. We have been conditioned to believe that speed is the solution to distance. But in the real universe, the laws of physics are not a highway. They are a prison wall. The speed of light is 458 meters per second. It is the absolute cosmic speed limit. Nothing with mass can reach it, and only massless particles like photons can travel at it. To us, on Earth, light seems instantaneous. You flip a switch, the room floods with illumination. It circles the globe 7.5 times in a single second. It feels infinite. But out here, in the black ocean between the CDs, light is agonizingly, painfully slow. Light is a snail crawling across a continent. Let's visualize this. Imagine you are riding a photon, a particle of light leaving the surface of the sun. Your destination is Pluto, the edge of our traditional maps. We are going to watch a loading bar of your journey. You launch. 1 second passes. You are barely away from the solar corona. 1 minute. You are still in the deep vacuum, nowhere near anything. 8 minutes and 20 seconds. You finally flash past Earth. We are just a blur, gone in an instant. 30 minutes, 40 minutes. The silence is deafening. There is nothing but empty, cold void. An hour passes. You are still traveling. 2 hours. You haven't even reached Saturn yet. 3 hours, 4 hours, 5.5 hours. Finally, you reach Pluto. 5.5 hours just to cross our own backyard. That is the speed of light. It is a crawl. And that is just to the edge of our planetary neighborhood. If you wanted to leave that CD-ROM floating in the ocean and reach the next one, Andromeda, moving at this blazing speed of light, you would be traveling for 2.5 million years. 2.5 million years. The entire history of the human species, from stone tools to the James Webb Space Telescope, fits into that timeline 10 times over. And you would still be floating in the dark, halfway between galaxies. I want to pause here, right in the middle of this void. I want to ask you something. And I really want you to take a moment to type your answer in the comments below, because this realization hits everyone differently. When you visualize that CD-ROM floating in the ocean, or that 5-hour loading bar to Pluto, what is the primary emotion you feel? Is it a sense of crushing insignificance? A feeling that nothing we do matters because we are so small? Or is it a strange sense of protection? That we are hidden away in a quiet corner of reality, safe from whatever monsters might be lurking in the deep ocean? Let me know. Are you terrified? Or are you relieved? Because the reality is, we are in a quarantine. This is the prison of speed. The vastness of the universe, combined with the finite speed of light, creates a cage effectively impossible to escape. Even if we perfected physics, even if we built a ship that could reach 99.9% of the speed of light, the absolute theoretical maximum, we are still trapped. To cross our own galaxy, just to go from one side of the Milky Way to the other, would take 100,000 years. Civilizations would rise and fall. Languages would be invented and forgotten. Stars would be born and die, all while your ship is still traversing the spiral arms of our own home. You would die on that ship. Your children would die on that ship. 1,000 generations would live and die in the metal corridors of that vessel before you even reached the halfway point. We look at the stars and we dream of a star federation, a galactic society where we trade with other worlds and map the cosmos. But the math says no. The math says that every civilization is an island, separated by oceans of time so vast that communication is functionally impossible. If we send a message to the other side of the galaxy today, saying hello, and someone is there to receive it, they won't get it for 100,000 years. If they reply immediately, we won't get the answer until 200,000 years have passed. By then, humanity might not even exist. The sun might have changed. The earth might be unrecognizable. A conversation with the universe is not a dialogue. It is a monologue, screamed into a void that swallows the sound. And this is just our galaxy. Remember the CD-ROM. There are 2 trillion other galaxies out there. The observable universe is 93 billion light-years across. If you left Earth today at the speed of light, heading for the edge of what we can see, you would never get there. Why? Because the space between the galaxies is expanding. The road is stretching out ahead of you, faster than you can drive down it. There are galaxies we can see in our telescopes today, glowing red and beautiful, that are already gone from our reach forever. They have crossed the cosmic horizon. They are receding faster than light. No signal we send will ever reach them. No ship we build can ever catch them. They are ghost images, postcards from a place that has been deleted from our future. We are not just imprisoned by speed. We are imprisoned by the expansion of the dark itself. We are living in a cosmic trap, a beautiful, glittering, terrifying trap. We think of space as the final frontier, a place of infinite possibility. But the laws of Einstein and the geometry of the void suggest something else. They suggest that we are quarantined. We are allowed to look. We are allowed to measure. We are allowed to marvel at the lights in the sky. But we are not allowed to touch. The universe is teasing us. It dangles the keys to reality right in front of our eyes. The swirling nebulas, the colliding black holes, the majestic superclusters like Laniakea. It lets us build telescopes to see them in high definition. It lets us calculate their mass and their age. But then it whispers, you can look, but you can never leave. We are trapped in our own backyard, and the fence is getting higher every second. This realization changes how we must look at the great nothing that lies between the stars. It is not just empty space. It is a barrier. It is a wall of time and distance so thick that it protects us, but also isolates us. And if you think the isolation of our galaxy is terrifying, you have not yet stared into the true abyss. Because even within this prison, there are places where the lights go out completely. Places where the galaxies themselves seem to fear to tread. We have talked about the structure of the universe, and we have talked about the speed that traps us within it. But there is a third component to this map. There are holes in the web. Imagine walking through a dense forest, surrounded by trees, and suddenly stepping into a clearing so vast, so empty, that you cannot see the other side. A place where the birds stop singing. A place where the wind dies. There is a region in space, not far from us, where the universe seems to have forgotten to create anything at all. A spherical void of such immense, suffocating nothingness that if the Milky Way were in its center, we wouldn't have known other galaxies existed until the 1960s. We are trapped by speed, yes, but at least we have neighbors. At least we have the light of the Milky Way. But what if we were somewhere else? What if we were in the dark? The prison of speed is one thing. The prison of the void is another. And as we turn our gaze from the blinding speed of light to the suffocating silence of the Buddha's void, we have to ask ourselves, Is it better to be trapped in a crowded room or free in an empty wasteland? The loading bar is still moving. It has barely left the sun, and we have a long, long way to go before we understand the darkness that is waiting for us. If we were to step off that loading bar, abandoning our photon vehicle to drift into the darkness waiting for us, we might find ourselves in the Bhuta's void. It is a name that sounds like a ghost story among astronomers, and perhaps it should be. This is the Great Nothing, a spherical region of space so colossally empty that it defies the very laws of probability that govern the rest of the cosmos. It spans 330 million light-years across. To put that into a perspective that the human mind can barely graze, if you were to place the Milky Way in the exact center of the Bhuta's void, we would not have discovered that other galaxies existed until the invention of the telescope in the 1960s. For all of human history, for every night our ancestors looked up, they would have seen only a profound, suffocating blackness. We would have believed, with absolute scientific certainty, that we were the only island of matter in an infinite ocean of nothing. The Bhuta's void is a place where the universe seems to have held its breath. Statistically, a region of this size should be teeming with at least 10,000 galaxies, a buzzing hive of starlight and civilization. Instead, we have found fewer than 60. It is a cosmic desert, a graveyard of potential where the seeds of creation simply fail to take root. When you look at the visualizations of our universe, this void appears as a gaping wound, a cold reminder that the distribution of existence is not fair, nor is it even. It triggers a primal fear in us, a thalassophobia of the skies. We fear the deep water because we do not know what is beneath us, but we fear the deep void because we know exactly what is there, absolutely nothing. But we do not live in the void. We are the fortunate ones. We reside in the rich, illuminated walls of the bubble. If you pull back further, retreating from the horror of the empty spaces, a new image begins to resolve itself. This is the moment where the chaos of the night sky transforms into the elegance of architecture. For a long time, we believed that galaxies were scattered through the universe like pebbles thrown into a pond, random, isolated, and drifting without purpose. We were wrong. The universe is not a scattering, it is a structure. And it is a structure that looks hauntingly, beautifully alive. As we map the positions of millions of galaxies, stripping away the illusion of solitude, we see that they are strung together, like pearls on invisible threads. These are the filaments of the cosmic web, vast bridges of dark matter that span billions of light years, guiding ordinary matter into long, glowing strands. The voids, like Bhutas, are merely the empty pockets between these filaments, the negative space that defines the art. But the static map tells only half the story. To truly understand our place in this colossus, we must look not at where the galaxies are, but where they are going. We must look at the flow. Here is a fact that should unsettle the ground beneath your feet. You are not sitting still. You are not just spinning on a planet, or orbiting a star, or circling the galactic center. The Milky Way itself is being dragged. We are caught in a gravitational riptide of epic proportions. When astronomers analyze the peculiar velocities of thousands of galaxies, subtracting the expansion of the universe to see their true movement, they discovered that we are rushing at 600 kilometers per second towards a specific point in the deep cosmos. We are not drifting, we are falling. This revelation redefines our home. We are not just a member of the local group or the Virgo supercluster. As the old textbooks claimed, those are just neighborhoods. We belong to something far greater, a structure that functions less like a map and more like a vascular system. This massive supercluster is known as Laniakea. In the Hawaiian language, It means immeasurable heaven, and it is the perfect name for the beast we live inside. Laniakea spans 520 million light-years and contains the mass of 100 quadrillion suns. But it is defined by its currents. Just as water flows down mountains into valleys, flowing into streams that merge into mighty rivers, gravity flows through the universe. In the visualizations of Laniakea, we see the streamlines of thousands of galaxies. They curve and twist, streaming in white-hot ribbons of starlight, all converging toward a singular gravitational basin. It looks like the delicate branching veins of a human leaf, or the complex neural pathways of a brain. It is organic. It pulses with the slow, heavy heartbeat of gravity. I want you to stop for a moment and let that sink in. We often look at the universe as out there, a cold, dead collection of rocks and gas completely separate from us. But look at the visualization of Laniakea again. Look at the streamlines. Now, look at the veins in your own wrist. Look at the way a river creates a delta. Look at the structure of a neuron. Do you think this is a coincidence? Or does it suggest that the laws of physics, from the microscopic to the macroscopic, follow the same fundamental blueprint? Does seeing our galaxy as just one tiny droplet in a massive flowing river make you feel insignificant, like a speck of dust? Or does it make you feel connected, a necessary part of a colossal living system? I invite you to leave a comment down below. When you see the universe flowing like a living thing, do you feel small, or do you feel part of the whole? I read every perspective, because in a universe this vast, your consciousness is the only thing that gives it meaning. We are flowing. But where are we flowing to? If the Milky Way is a droplet in the river of Laniakea, what lies at the mouth of the river? What is the heart of this beast? All the streamlines in our supercluster, all those thousands of rushing galaxies, are converging on a single point, a region of space so dense with mass, so heavy with gravity, that it is reeling in the universe like a fisherman hauling in a net. We call it the Great Attractor. It is a name that sounds like it belongs in science fiction, an ominous title for an ominous anomaly. It sits at the center of the Laniakea watershed, the bottom of the gravitational valley. And here is the final cosmic joke, the twist in the detective story that keeps astronomers awake at night. We can't see it. By a cruel stroke of cosmic alignment, the Great Attractor lies directly behind the zone of avoidance. This is the region of the sky obscured by the dense dust and gas of our own Milky Way galaxy. We are trying to look out the window, but the curtains are drawn. We can see the rivers flowing toward it. We can measure the speed at which we are being dragged toward it. We can feel its invisible hand gripping our galaxy, pulling us across the void at millions of miles per hour. But we cannot see the thing itself. We are rushing blindly into the dark, pulled by a heart we are forbidden to witness. Some theories suggest it is a massive confluence of older superclusters. Others whisper of exotic physics or defects in the texture of space-time. But for now, it remains a shadow, a ghost in the machine. It reminds us that for all our telescopes, for all our infrared eyes, like the James Webb, the universe still keeps its deepest secrets hidden in plain sight. We are detectives arriving at the scene, seeing the footprints, seeing the shattered glass. But the culprit is hiding behind the very light we used to see. This is the reality of our existence. We are not static statues in a museum. We are travelers. We are blood cells pumping through the veins of a cosmic giant, rushing towards a heart that beats in the darkness. The scale of Laniakea teaches us that the universe is not just a place. It is a process. It is a flow. And when we zoom out far enough, past the superclusters, past the flows and the attractors, the image shifts one last time. The veins of Laniakea are just one knot in a much larger tapestry. When we simulate the entire observable universe, the glowing filaments of galaxies connect into a structure that is unmistakably familiar. It is the cosmic web. But to the human eye, it looks exactly like a neural network. The universe looks like a brain. The filaments are the neurons. The galaxy clusters are the synapses. The voids are the empty space between thoughts. Are we living inside a mind? Is the consciousness that asks, "Why are we here?" merely the universe trying to understand itself? As we stare at the glowing web of the cosmos, we are not looking at a foreign object. We are looking in the mirror, and the reflection is vaster, stranger, and more beautiful than we ever dared to imagine. The veins of the cosmos are pulsing, and we are the blood. If we are the blood pulsing through the veins of this cosmic nervous system, then we must ask, what lies between the nerves? When you look at that simulation of the cosmic web, your eye is naturally drawn to the light. You focus on the glowing filaments, the knots of superclusters, the bright, warm architecture of existence. But the light is a distraction. To understand the true nature of this beast we inhabit, you have to look away from the shine. You have to look at the gaps. Between the filaments of the cosmic web lie the great voids. These are not merely empty pockets of space. They are vast, spherical abysses that defy human comprehension. And among them, one stands out as the ultimate expression of emptiness. It is a region of space located in the constellation Boötes, and astronomers simply call it the Great Nothing. Imagine for a moment that you are floating in the center of this void. You are 700 million light-years from Earth. In our corner of the universe, the night sky is a tapestry of stars. But here, if you were to look out the window of your spaceship, you would see absolute crushing blackness. The Boötes void is a sphere of nothingness, 330 million light-years across. To put that in perspective, that is roughly 0.27% of the entire observable universe, a hole so massive that it shouldn't exist. Statistically, a region of space this size should be teeming with life and light. It should harbor at least 10,000 galaxies, a buzzing metropolis of civilizations and stars. But when we point our telescopes into this abyss, we don't find 10,000 galaxies. We find 60. Just 60 lonely islands of light, drifting in a sea of eternal dark. If the Milky Way had been in the center of the Boötes void, we wouldn't have known there were other galaxies in the universe until the 1960s. We would have looked up and thought we were truly, terrifyingly alone. This brings us to a sensation that is usually reserved for the ocean: thalassophobia, the intense, primal fear of deep bodies of water. The fear of what lurks beneath the surface, unseen and silent. We tend to think of space as a ceiling above us, but the Boötes void teaches us that space is actually an ocean, and we are merely clinging to a piece of driftwood on the surface, blissfully unaware of the depth beneath our feet. Because here is the twist in our detective story. The emptiness isn't just empty. It is heavy. It is waiting. When we look at the universe, we are behaving like detectives arriving at a crime scene where 95% of the evidence has been stolen. We look at the beautiful spiral galaxies spinning with majestic grace, and we marvel at them. But when we run the math, the physics breaks. Decades ago, an astronomer named Vera Rubin noticed something that didn't make sense. She watched stars at the edges of galaxies orbiting at breakneck speeds. According to the laws of gravity, they should have been flung out into the void, like a car taking a corner too fast. There wasn't enough visible mass, stars, gas, dust, to hold them in. By all accounts, these galaxies should have torn themselves apart billions of years ago. But they didn't. Something invisible was holding them together. A ghostly scaffolding that we cannot see, touch, or interact with. Yet it exerts a gravitational grip, stronger than all the stars combined. We call it dark matter. But don't let the name fool you. Dark matter is just a placeholder, a label for our own ignorance. It is the shadow in the corner of the room that refuses to step into the light. We know it is there because we can see the light bending around it, but we have no idea what it is. And it gets worse. While dark matter pulls things together, there is another force, dark energy, that is tearing them apart. This is the invisible hand, stretching the fabric of space-time, pushing galaxies away from each other faster and faster, driving the universe toward a cold, lonely future. I want you to pause here for a second. We often talk about space as a frontier of discovery, a place of wonder. But these facts paint a different picture, one of a universe that is mostly hidden from us. Does the idea of invisible forces dominating our reality make you feel smaller? Or does it make the visible world feel more precious? I'm curious where you land on this. Do you find comfort in the mystery? Or does the dark forest of the universe unsettle you? Take a moment to leave a comment below. I want to read your theories on what the dark sector really is. Now, let's look at the numbers, because this is where the true horror and the true beauty reveals itself. When we tally up everything we can see, every star in every galaxy, every planet, every gas cloud, and every atom in your body, it amounts to less than 5% of the universe. 5%. Think about that. Everything you have ever loved, every historical event, every sunrise, every scientific discovery, the entire history of the human race, and the burning fusion of 1 trillion suns. It is all just froth. We are the bioluminescent foam floating on top of a dark, invisible ocean that makes up 95% of reality. This is the aha moment that changes everything. We grow up thinking that matter, atoms, protons, electrons, is the standard. We think we are the rule, but we are not the rule. We are the exception. We are a cosmic freak accident. Baryonic matter, the stuff that makes you and me, is a rare exotic contaminant in a universe built of darkness. This realization fundamentally shifts the overview effect. When you looked at Earth from space, you felt the fragility of the planet. But when you look at the visible universe from the perspective of the dark sector, you feel the fragility of existence itself. We are huddled around the campfire of the visible spectrum, telling ourselves stories to keep the dark at bay. But the fire is small, and the night is very, very long. The universe is not what it seems. It is not a kingdom of light with a few patches of darkness. It is a kingdom of darkness with a few rare, fleeting sparks of light. And you are one of those sparks. The atoms in your blood, the calcium in your bones, the carbon in your breath. These are rare treasures, forged in the death throes of stars, clinging together against the dissolving power of dark energy. To exist as a being of matter is to be a defiance of the void. You are a lighthouse in the Bhuta's void. And while the great nothing surrounds us, pressing in from all sides, with its invisible mass and its accelerating expansion, it has not extinguished us yet. We are the detectives in this thriller, yes, but we are also the survivors. As we stare into the deep ocean of the cosmos, the silence is deafening. The Bhuta's void suggests that there are places where the web of life has failed to take hold, vast deserts where the seeds of galaxies never sprouted. It forces us to confront the possibility that the universe is not designed for us. It is indifferent. It is a machine running on invisible gears, and we are just the dust caught in the mechanism. But there is a strange comfort in this. If the universe is mostly empty, mostly dark, and mostly hostile, then the fact that we are here at all is a statistical miracle. We shouldn't be here. The odds of a universe balanced perfectly to allow for the formation of atoms, let alone stars, let alone life, are so infinitesimally small that it feels like winning the lottery every single second of every single day. The great nothing is not just a void, it is a mirror. It shows us what the universe would look like without the lucky accident of matter. It shows us the default state. And by contrast, it shows us the immense value of the 5%. The dark forest is real. The ocean is deep and dark and full of things we cannot see. But we're the bioluminescence. We are the way the universe breaks its own silence. So, as we leave the Buddha's void behind and travel back toward the filaments of light, remember this. The mystery of the dark sector is not just a puzzle to be solved. It is a reminder of our rarity. We are drifting through a ghost town, yes, but we are the ones who brought the lanterns. And yet, even with our lanterns, there is a limit to how far we can see. The darkness is not just physical, it is temporal. As we gaze out from our rare island of matter, we are not just looking across space, we are looking back in time. And there is a horizon beyond which even our most powerful instruments cannot see. A wall where the past and the future collide in a way that breaks the human mind. The dark ocean has an edge, and we are sailing straight toward it. But while we stare out at that distant wall of the past, seeking the edge of the dark ocean, we often forget to look down. We forget that the ocean we are drifting through has deep, invisible currents. And if you follow those currents to their absolute source, you do not find a wall. You find a drain. You find the monsters of gravity. We tend to think of gravity as a force that holds things together. It is the gentle hand that keeps our feet on the ground and the moon in our sky. But that is a comfortable lie we tell ourselves to sleep at night. In the deep universe, gravity is not a hand, it is a mouth. It is the sculptor of galaxies, yes, but it is also their eventual executioner. Every spiral arm of stars, every nebular nursery, and every solar system is ultimately dancing around a central, terrifying point of infinite density. We call them supermassive black holes, but the name feels insufficient. It implies a hole, an empty space. But these are not empty. They are the heaviest objects in existence, so heavy that they puncture the fabric of reality itself. To understand the true scale of our universe, we must confront the largest of these titans. We must look into the abyss of Ton 618, located over 10 billion light-years away. In the constellation Canes Venatici, Ton 618 is not merely a black hole. It is a hyperluminous quasar, a beacon of light shining with the brilliance of 140 trillion suns. But the light is the death scream of matter being torn apart. At its center lies a black hole of such incomprehensible magnitude that it breaks our ability to visualize scale. Let us try, though. Let us try to fit this monster into our reality. Imagine the sun. It is massive enough to hold 99.8% of all the mass in our solar system. Now, imagine a black hole with the mass of 66 billion suns. That number is just a sound, so let's build it. If you were to take every star in the Milky Way galaxy, all 100 billion of them, and crush them down, you would start to approach the mass of this single object. But mass is hard to see. Let's talk about size. Let's talk about the event horizon, the point of no return, the black sphere from which light itself cannot escape. If we were to teleport Ton 618 into the center of our solar system, replacing the sun, we would not just be burned or crushed. We would simply cease to be. But the horror is in the distance. The event horizon of Ton 618 is so large that it wouldn't just swallow Mercury, Venus, and Earth. It would not just swallow Mars and the asteroid belt. It would swallow Jupiter, Saturn, Uranus, and Neptune. But it doesn't stop there. It would consume the Kuiper Belt, the home of Pluto. It would reach out and consume the scattered disk. It is so large that its radius would extend roughly 390 billion kilometers out from the center. To put that in perspective, Voyager 1, the farthest human-made object in history, has been traveling at nearly 40,000 miles per hour for nearly half a century. It is currently about 24 billion kilometers away. If the Voyager 1 were fleeing from the center of Ton 6DY, it would not even be 10% of the way to the exit. It would still be deep, deep inside the belly of the beast. This black hole is so vast that it would swallow everything up to the inner edge of the Oort cloud, the very shell of our solar system. A beam of light, moving at the fastest speed in the universe, would take a week just to cross the diameter of its shadow. In our solar system, light crosses from the Sun to Earth in 8 minutes. Inside Tuan 6-18, light is trapped in a week-long journey to nowhere. This is not just an astronomical object. This is a region of space where the concept of distance loses its meaning. I want you to pause for a moment and really sit with that image. A single shadow that is larger than our entire history of exploration. When you visualize a monster of that scale, does it trigger a sense of existential dread? Or is there a strange comfort in knowing something that big exists? Is it terrifying, or is it awe-inspiring? I read every comment, so let me know down below. Does the scale of Ton 6-18 make you feel small in a bad way, or small in a good way? When we look at something like Ton 6-18, we are looking at the universe's cosmic eraser. We are conditioned to think of matter as solid stuff, atoms, protons, electrons. But inside the event horizon, those definitions evaporate. A black hole is the bathtub drain of the cosmos. As matter spirals in, it is superheated to millions of degrees, glowing with that fierce violet light we see in our telescopes. But once it crosses the threshold, it vanishes. It doesn't just disappear from sight, it disappears from our physics. This is the aha moment that keeps astrophysicists awake at night. A black hole is the specific point in the universe where math breaks down. The equations we use to describe the world, general relativity, which explains gravity, and quantum mechanics, which explains particles, refuse to work together inside that dark sphere. They crash. They yield infinity as an answer, which in physics means we don't know. Inside that horizon, geometry replaces matter. The gravity is so intense that space curves infinitely inward. If you were to fall in, you wouldn't just be crushed. You would be stretched into a stream of subatomic particles in a process literally called spaghettification. But more profoundly, your timeline would shatter. To an outside observer, watching you fall toward Ton 6-18, you would never actually cross the edge. As you approach the horizon, the light reflecting off you would shift to red, deeper and deeper, stretching into infrared, then radio waves, until you simply faded from view. But because of the intense gravity warping space-time, time itself slows down near the edge. To the observer, you would appear frozen there for eternity, a ghostly image stuck on the surface of the dark star, never truly entering, never truly leaving. You become a permanent fixture of the galaxy's history, preserved in light long after you are gone. But from your perspective, falling in, you would cross the horizon in an instant. You would look back and see the universe seemingly speed up, the stars aging and dying in fast forward as you plunge toward the singularity, the center point where density becomes infinite and space becomes zero. This brings us to the most haunting realization about these monsters. They are not just destroyers. They are the vaults. They are the future caretakers of the universe. We live in the Sideriferous era, the era of stars. It is a bright, warm, energetic time. But this era is a blink of an eye in the lifespan of the cosmos. Stars run out of fuel. The biggest ones explode. The smaller ones fade into white dwarfs and eventually cool into black dwarfs. But the black holes, they are just getting started. Ton 689 and its kin are the anchors that will survive the end of the starlight. When the last sun burns out and the universe plunges into the degenerate era, these supermassive black holes will be the only sources of energy left. Civilization, if it still exists trillions of years from now, will not huddle around stars. They will huddle around the accretion disks of black holes, warming themselves by the friction of matter falling into the dark. They will treat these monsters not as predators, but as furnaces, and eventually, even the black holes will die. But their death is so slow, it defies comprehension. Through a process called Hawking radiation, they will slowly evaporate, leaking particles back into the void over googles of years. A black hole the size of Ton 680 would take so long to evaporate that if you wrote the number of years on a sheet of paper, the paper would be wider than the observable universe. So when you look at the image of a black hole, or when you visualize the dark heart of our own Milky Way, do not just see a drain, see a time capsule. These are the objects that will witness the final funeral of the universe. They are the hard drives, where the data of existence is stored when the power goes out. They are the terrifying, silent guardians that will watch over the dark long after we and our stars have turned to dust. This realization shifts our perspective on the void we discussed earlier. The Buddha's void was empty space, terrifying because of its nothingness. Ton 618 is terrifying because of its somethingness. It is too much reality in one place. It is a reminder that the universe is not just vast distances, it is also extreme densities. It is a place where the rules of the game can be rewritten if you just gather enough matter in one spot. But if black holes are the anchors of the galaxies and voids are the vast oceans between them, what happens to the structure itself? If we zoom out even further, past the black holes, past the voids, and look at the network they form, we see something that looks suspiciously familiar. We see a web. We are not just living in a galaxy anchored by a monster. We are living in a strand of a colossal web, a structure so massive, it makes Ton 618 look like a subatomic particle. We are flowing through the veins of a giant, and to understand our place in that body, we must look at the flow. We must look at where we are going. We are not stationary, we are being dragged. The monster in the center of our galaxy is pulling us, yes, but something else is pulling the galaxy itself, something beyond the horizon, something that makes the monsters of gravity look like mere pebbles in a stream. As we leave the event horizon behind, escaping the grip of the time-stopping gravity, we have to ask, if the black holes are the drains, where is the river flowing? What is the great attractor? And why is our entire region of the universe moving toward it with such desperate speed? The dark ocean doesn't just have monsters, it has a current, and we are caught in the riptide. That current is vast. If you could pull your consciousness out of your body, float up past the stratosphere, beyond the orbit of the moon, and keep pulling back until the Milky Way itself is just a spinning disk of light in the distance, you would begin to see the true shape of our home. We are not isolated. We are part of a structure so colossal, it defies the very architecture of our imagination. You are looking at Laniakeo. In the native Hawaiian tongue, it means immeasurable heaven. and there has never been a more fitting name. It is a supercluster of galaxies spanning 520 million light-years, containing 100,000 galaxies, each one a city of stars teeming with potential worlds. And it looks alive. When we map the movement of these galaxies, we don't see a random scatter of buckshot. We see a vascular system. We see veins of light. Thousands of galaxies are flowing like rivers, streaming along invisible gravitational filaments, all draining toward that mysterious gravitational anomaly you felt earlier, the Great Attractor. It is the beating heart of our local universe, a dense knot of matter pulling us in at 600 kilometers per second. We are just a drop of water in this cosmic watershed, sliding down the gravity well, along with Andromeda and thousands of others. It feels like a community. It feels like a grand, interconnected ecosystem where gravity is the weaver, binding us all together in a chaotic but unified dance. But this sense of connection is a beautiful lie. Or rather, it is a temporary truce in a war that has been raging since the dawn of time. While gravity tries to pull the universe together, building these magnificent webs and clusters, there is a darker, more silent force at work. It is the invisible hand that is slowly strangling the sky. We call it dark energy. And it is winning. While we rush toward the Great Attractor, the space between the superclusters is stretching. This is the hardest concept for the human mind to visualize, because we are creatures of static environments. When you walk across a room, the floor doesn't expand beneath your feet. But the universe is not a floor, it is a fabric, and that fabric is being pulled apart. Imagine drawing dots on a balloon and then inflating it. The dots aren't moving across the rubber. The rubber itself is growing, pushing the dots apart. That is our reality. The universe is expanding, and it is accelerating. This leads us to one of the most terrifying realizations in modern cosmology. There is a limit to what we can see. There is a hard edge to our reality. We call it the cosmic horizon. Because the universe is expanding, distant galaxies are moving away from us. The farther away they are, the more space there is between us and them, and the faster that space expands. Eventually, you reach a distance where the space is expanding faster than the speed of light. Let that sink in. The space is expanding faster than light can travel through it. This means that a photon of light, leaving a galaxy on the other side of that horizon, is like a runner on a treadmill that is moving faster than they can run. No matter how long that photon travels, no matter how hard it pushes through the void, it will never reach us. It is sweeping upstream against a current that is too strong. Those galaxies are lost to us forever. They are technically still there, existing in the same moment of time as we are, evolving, perhaps hosting civilizations that are looking back into the dark. But we can never send them a signal, and they can never send one to us. They have slipped over the edge of the waterfall. Every second that ticks by on your watch, a distinct region of the universe passes beyond this horizon. It is a silent hemorrhage. We are losing the universe, piece by piece, galaxy by galaxy. The night sky is technically getting emptier every single moment. We just don't live long enough to notice the lights going out. But let's pause here for a moment, right at the edge of this terrifying precipice. I want to ask you something, and I want you to really think about it before we move on. When you hear about this, about galaxies disappearing forever, about the universe stretching out into an unreachable void, what is the dominant emotion you feel? Is it a cold, hollow sense of isolation, a fear of the dark? Or is it a strange, liberating comfort in knowing that our problems are so incredibly small against this scale? It is the ultimate duality of the overview effect, terror and peace, existing in the same heartbeat. I want to know which side of the coin lands for you. Let me know in the comments below. Does the vastness make you feel lonely, or does it make you feel free? Because how we answer that question determines how we face the future. And the future of the universe is a story of profound isolation. If we fast forward the timeline, not by years or centuries, but by eons, the war between gravity and dark energy comes to a definitive end. Gravity loses. The expansion becomes so rapid that it rips the superclusters apart. The filaments of Laniakea will snap. The great attractor will lose its grip. We need to talk about the cosmic orphan. Imagine a civilization born 100 billion years from now. Let's say they arise on a planet orbiting a stable red dwarf star, long after our sun has swelled into a red giant and faded into a white dwarf. These future astronomers will build their telescopes. They will polish their mirrors and point them at the sky view, just as we did. They will ask the same big questions. What is out there? Where did we come from? But when they look up, they will see something very different from what we see. By then, all the other galaxies, Andromeda, the Triangulum, the entire Virgo cluster, will have merged with us or been pushed beyond the cosmic horizon. The expansion of space will have carried the rest of the universe away at faster than light speeds. The light from the Big Bang, the cosmic microwave background that gave us the clue to our creation, will have been stretched so thin it will be undetectable. These future beings will look up and see nothing. They will see the stars of their own merged galaxy, and beyond that, only an endless, inky, static void. They will have no way of knowing that the universe is expanding. They will have no evidence of the Big Bang. They will conclude, based on all their best science, that they are the entire universe. They will think their galaxy is an island of matter in a static, eternal, infinite sea of nothingness. They will believe they are truly, completely alone. They will be cosmic orphans, cut off from the history of creation. They will construct models of physics that work perfectly for their observation, but are fundamentally wrong about the nature of reality. They will never know about the billions of galaxies that once danced in the dark. They will never know about Laniakea. They will never know about us. This realization brings us to a startling, beautiful truth about our own existence. We often lament that we were born too late to explore the Earth and too early to explore the stars. We feel like we missed the party. But cosmologically speaking, we have won the lottery. We are living in the Sideriferous era, the era of stars. This is the prime of the universe's life. It is the brief, brilliant summer between the violent spring of the Big Bang and the long, freezing winter of heat death. We are privileged. We are the only ones who will ever get to see the universe in its full glory. We exist in that narrow window of time where the galaxies are close enough to be seen, where the evidence of our origins is still ringing in the radio waves of the sky, and where the night is filled with a diverse tapestry of neighbors. We can see the past. We can see the structure. We can see the web. The future is dark, not in a metaphorical, pessimistic sense, but in a literal, physical sense. The universe is marching toward a state of high entropy. Stars run on fuel, and the universe has a limited tank. The rate of star formation is already dropping. The biggest, brightest blue stars are dying out, leaving behind the slower burning red dwarfs. Eventually, even they will flicker out. If you were to watch a time-lapse of the future, you would see the lights of the galaxies turning from a brilliant white blue to a dim, tired red. Then, one by one, they would wink out. The era of starlight is a temporary anomaly. For the vast majority of the universe's timeline, trillions upon trillions of years, it will be a graveyard of black holes, neutron stars, and cooling white dwarfs drifting through a cold, expanding dark. Civilizations of the far future might huddle around the last dying embers of black hole accretion disks, harvesting the rotational energy of the singularity just to keep their machines running, telling myths of a time when the sky was blazing with light. But that is not our time. That is not our burden. We are here now. We are the witnesses. In a way, the universe needs us right now. Without eyes to see the galaxies before they disappear, without minds to map the Laniakea supercluster before it is torn apart, does that grandeur even exist? We are the archivists of the cosmos. We are capturing the image of the universe before it fades. So when you look at the James Webb images, when you see those thousands of galaxies smeared across the deep field, you aren't just looking at pretty wallpapers. You're looking at an endangered species. You're looking at a vanishing horizon. You're seeing the last lights before the long dark sets in. This changes how we must look at our own little corner of space. If the universe is becoming a lonely place, if the inevitable flow of time is to separate us from our neighbors, then the connections we have right now become infinitely more precious. We are currently drifting through the void on a single fragile rock. We are shouting into the dark, hoping for a reply, hoping to find just one other mind in the stariferous era to share this view with. And yet, we are met with silence. The silence is heavy. It is the silence of the Buddha's void. It is the silence of a dark forest where perhaps everyone else is hiding. But maybe the silence isn't empty. Maybe we just aren't listening on the right frequency. Or maybe, just maybe, we are the first to wake up. As we stare out into the expanding dark, trying to find meaning before the horizon closes in, we have to turn our gaze to the only things that have physically traveled into that abyss on our behalf. We have to look at our scouts. We have sent emissaries into the dark, tiny metal contraptions of gold and aluminum, carrying pictures of our children, recordings of our laughter, and maps of our location. They are the only physical proof that we ever existed, drifting now into the interstellar medium, leaving the warmth of our sun behind forever. They are the voyagers, and their journey is the perfect mirror to our own. They are moving into the freeze, their batteries dying, their transmitters fading, sailing toward stars that will be dead by the time they arrive. But they go anyway. Why? Because to stop is to accept the dark. To stop is to accept that the horizon is the end. And if there is one thing humanity refuses to accept, it is the limit of our reach. We know the universe is dying. We know the lights are going out. But as long as we have breath, and as long as we have eyes to see, we will not let the night take us without a witness. We will watch the lights until the very last one fades. This is why we build the telescopes. This is why we look for the great attractor. This is why we map the veins of Laniakea. We are trying to memorize the face of the universe while it is still smiling at us. But what happens when we stop looking? What happens when the internal universe, the mind, collapses just as the external one expands? To understand the death of the universe, we must understand the delicate, improbable miracle of the observer. We must look at the odds. The universe is 93 billion light-years of hostility. Radiation, vacuum, crushing gravity, freezing cold. It is a machine designed to kill complex life. And yet here you are, breathing, thinking, understanding. You are a statistical impossibility. In a universe that is 99.9% empty void, you are the 0.01% that matters. You are the universe experiencing itself, and that implies a responsibility. If we are the only ones who can see the stars, then we have a duty to look. We have a duty to feel the awe. Because if we don't, the universe remains a cold, unseen equation. We provide the meaning. We provide the scale. As the expansion accelerates and the cosmic horizon draws tighter around us, we must remember that we are not just orphans drifting in the dark. We are the memory keepers. We are the last lights. And as we drift further from our neighbors, carried by the expansion into the solitude of the future, we have to ask ourselves one final question. If we are the universe's way of knowing itself, what did it learn when it created us? Did it learn that it is vast? Did it learn that it is beautiful? Or did it learn that it is lonely? The answer lies not in the stars, but in the silence between them. That silence is growing. The gaps are widening. The night is getting deeper. But we are still here. And we are still watching. The current drags us on, past the local group, past the superclusters, toward a destiny of isolation. But for this brief, shining moment in the stariferous era, we are together. We see the web. We see the light. And perhaps that is enough. The view from here is magnificent. But the window is closing, and as we turn our attention back to the local machinery of our solar system, we realize that even our own star has an expiration date. The clock is ticking on every scale, from the expansion of the cosmos to the beating of your heart. Time is the ultimate predator, and it is hunting us all. Time is the ultimate predator, and it is hunting us all. That was the heavy truth we were left with as we stared into the abyss of the future. It is a realization that sits in the chest like a stone, a cold, hard fact derived from the expansion of the Laniakea supercluster and the inevitable decay of the stars. When you look at the universe through the lens of deep time, it is easy to feel like a victim. We feel like prey, scurrying across the surface of a dying rock, waiting for the cosmic clock to run out. The sheer scale of the data we have analyzed, the billions of light years of empty dark, the freezing voids, the relentless pull of the great attractor, can trigger a profound sense of nihilism. You look at the numbers, and you feel like a glitch, a meaningless accident in a cold, indifferent machine. But I want you to stay with me, because we are about to flip that feeling upside down. We're going to take that crushing weight of insignificance and transmute it into the most empowering realization of your life. The vastness is not a testament to our irrelevance. It is the proof of our value. Consider the environment we have just explored together. We have traveled from the edge of the observable horizon back to our local group. And what have we seen? We have seen that the universe is not a garden. It is a violent, radioactive engine of destruction. If you were to be teleported to a random set of coordinates in the cosmos right now, the statistical probability is that you would die instantly. You would be frozen now in the vacuum of deep space, incinerated inside the fusion shell of a star, crushed by the gravitational singularity of a black hole, or ripped apart by the invisible sleet of gamma radiation. 99.9% of the universe is lethal to life. It is a place of extreme violence, governed by laws that do not care about your existence. Matter is smashed. Energy is dispersed. Entropy is relentless. The default state of the universe is dead, cold, and empty. The Bhuta's void, that terrifying region of nothingness we discussed, is not an anomaly. It is closer to the norm than we would like to admit. The cosmos is a hostile ocean, and for billions of light years in every direction, the waters are dark and the depths are crushing. And yet, here you are, breathing, thinking, feeling. Against odds so astronomical, they defy the language of mathematics. You exist. Let's revisit that famous concept, the pale blue dot. But let's look at it with the fresh, high-fidelity eyes of the James Webb Space Telescope. That tiny pixel of light, suspended in a sunbeam, is not just a place. It is a fortress. It is a statistical miracle. We live on a rock that happens to be the precise distance from a stable, long-burning star, protected by a giant gas planet, Jupiter, that acts as a gravitational shield, eating asteroids that would otherwise shatter our world. We are wrapped in a magnetic field that deflects the solar wind, and we are stabilized by a moon that keeps our planetary tilt in rhythm, granting us the seasons that drive our biology. If the observable universe were the size of the Earth, our entire galaxy would be the size of a CD-ROM, and our solar system would be invisible to the naked eye. And yet, in all that sand, in all those billions of galaxies, we have yet to find a single other voice. We have yet to find another pair of eyes, looking back at us. This is the rare Earth reality. It suggests that while simple life might be common, the complex conscious life that can build telescopes and wonder about its own origin is exceedingly rare. This pivots our perspective entirely. If the universe is vast and mostly dead, then life is not a trivial byproduct. It is the rarest commodity in existence. We are the diamond in the rough. We are the gold dust in the river of entropy. When you look at the night sky, do not feel small, because the universe is big. Feel important, because the universe is empty. And you are not. You are the exception. You are the victory. This brings us to the true nature of our role in the cosmos. Think about what you are. Physically, you are a collection of atoms forged in the hearts of dying stars billions of years ago. Carbon, nitrogen, oxygen. These elements were cooked in the nuclear furnaces of ancient suns that exploded and scattered their ashes across the void. Those atoms drifted through the darkness for eons, coalesced into a planet, and eventually, through a process we still barely understand, arranged themselves into a pattern that could wake up. You are the universe, looking at itself. This is the metaphor that changes everything. We are the way the cosmos knows it exists. Without you, without us, the universe is just a play with no audience. It is a magnificent, silent fireworks show that no one sees. Does beauty exist if there are no eyes to behold it? Does the vastness matter if there is no mind to comprehend it? A star can burn, but it cannot know that it burns. A black hole can consume a solar system, but it cannot mourn the loss. A nebula can birth 1,000 suns, but it cannot feel awe at its own creation. But you can. You are the sensory organ of the infinite. Through your eyes, the universe perceives its own grandeur. Through your mind, it calculates its own age. Through your heart, it feels the terror of its own scale. We are not separate from the universe. We are the part of it that has awakened. We are the glint of consciousness in a sea of unconscious matter. And that responsibility is staggering. It means that we are the custodians of meaning. In a universe that is largely defined by dark energy pushing things apart, we are the force that pulls things together. Through art, through science, through love, through memory. We are the storytellers in a library that is burning down. And even if the fire eventually takes us, the fact that we read the books, that we understood the story, that we felt the emotions, that matters. This realization cures the paralysis of nihilism. It replaces the fear of being small with the pride of being rare. We are the candle in the dark room. The darker the room, the more important the candle becomes. The vastness of the void does not diminish our flame. It defines it. It makes every moment of consciousness, every act of kindness, every discovery, and every question infinitely precious. We are the 1% that can feel, against the 99% that is numb. So as we stand here on this fragile blue marble, looking out into the deep field, we must recognize that we are not intruders in the cosmos. We are its apexes, We are the point of it all. The silence between the stars is not a sign of our isolation. It is the quiet of a cathedral waiting for a choir. And we are that choir. We are the song the universe sings to itself to keep the darkness at bay. The view from here is magnificent, not because of the galaxies we see, but because there is someone here to see them. We have looked into the face of the predator, that is time, and we have realized that while it may hunt us, it cannot negate us. We have stolen fire from the gods of physics, and we have used it to light up the dark. So I leave you with this final question to carry into the night. If we are indeed the universe's only way of experiencing itself, does that make us the masters of this cosmos or its caretakers? Are we here to conquer the void or to fill it with meaning? The window of our existence is narrow, but the view is infinite. If this journey through the dark and the light has shifted your perspective, if you feel the weight of that responsibility, then join us. Subscribe to the channel and become a part of this exploration. Leave a comment below with your answer. Are we a cosmic accident or the universe's greatest creation? I read every single thought you share because every perspective adds to our collective understanding. Let's keep watching the skies together.